Find the radius of the quarter circle. Label points A, B, O, C, and D. O is the center of the quarter circle. We assigned angle BOA to be equals to theta. It means that angle labeled COD equals 45 degrees minus theta. Also, line A, O equals line D, O which equals to radius of the quarter circle. This implies that from triangle AOB, line A be divided by R equals sine theta, which equals to 1 divided by R. We call it equation 1. From triangle COD, it follows that line CD divided by R equals sine 45 degrees minus theta, which equals 2 divided by R. We call it equation 2. Substitute in equation 3. Sine theta divided by the ratio of cosine theta minus sine theta to the square root of 2 equals to half. Cross multiply and we have that the product of 2 and the square root of 2 times sine theta equals cosine theta minus sine theta. Combine like terms. It implies that 2 times the product of the square root of 2 and sine theta plus sine theta equals cosine theta. Factorize. Sine theta times the sum of 2 times the square root of 2 and 1 equals cosine theta. Divide by cosine theta and we have the equation shown. Divide the equation by the sum of 2 times square root of 2 and 1. Sine theta divided by cosine theta equals 1 divided by the sum of 2 times square root of 2 and 1. But tan theta equals sine theta divided by cosine theta. It follows that Pythagoras theorem. The square of R equals the sum of the square of line A, B, and the square of line B, O. Substitute values, and we have that the square of R equals the sum of 1 and the square of the sum of 2 times the square root of 2 and 1, which equals the sum of 10 and 4 times the square root of 2. Take the square root of the equation. It implies that R equals the square root of the sum of 10 and 4 times the square root of 2 in centimeters, or 3.96 centimeters, to 2 decimal places.